Hello and a warm welcome to the Tamil Nadu Brief Weekend Edition. I'm Sam Daniel. NISAR, the biggest ever satellite collaboration between the United States and India, was successfully put on its orbit from Sriharikota. Joining us, a small team from NASA and Caltech. Dr. Jural, if I can begin with you. This successful launch, how special is it for NASA and Caltech?
NISAR is an incredible special mission for both NASA as well as ISRO. NISAR is going to be collecting more data than any other radar mission has collected globally. All the data are free and open. We're going to be able to study the living Earth, the solid Earth, so we've got earthquakes, volcanoes, landslides, and the frozen Earth. So this is both the Antarctica as well as the Arctic. And the amount of data that we're collecting is going to have new discoveries that we didn't even know were there.
Professor Mark Simon, for a common person to understand, this is being touted to be a life-saving mission. In what aspects do you think this is going to help India or the United States or the larger world community in terms of its life-saving potential?
So NISAR is an extraordinary platform. It provides a kind of observation, this dual frequency radar, that allows us to monitor the entire globe with very high spatial resolution at the level of meters, the size of a house or an apartment, all the way to the size of continents. It has a very frequent repeat time, so we can come back and revisit and re-image the Earth over and over and over again. It allows us to monitor where things are changing. If it is landslides or earthquakes or volcanoes, we are able to monitor them to see if things are changing from their behavior in the past and whether they deserve more careful attention. When disasters actually occur, this technology with radar allows us to see day or night through clouds all over the globe, and it allows us to assess very quickly which areas have experienced devastation and which areas have not. This technology allows us then to optimally apply resources for emergency response and to also quickly assess the extent of the damage to help the recovery on timescales of weeks to years as we understand the scale of a natural disaster. But perhaps even more important is that this NISAR mission is designed to enable the basic science to understand these processes, whether it is landslides, changes in aquifers, changes in vegetation and agricultural use. And so it allows us a whole new perspective that we didn't have before, so we can understand the basic processes, and that understanding can then be eventually translated into new applications, sometimes new businesses, and certainly ability to save lives eventually by providing a more resilient society.
Dr. Sangamitra, this project was built working in two different countries, from California in the US, Karnataka in India, across continents. How challenging was this, and what was so exciting about this?
Thank you for asking that interesting question. And I am very excited to say that it was definitely a learning experience for both sides of the continent, sitting across like 9,000 miles apart, working day and night with 12 and a half hours of time difference between the west coast of the US and India. But day and night, these great minds of scientists and engineers work together seamlessly. We never felt that they are working in two different areas. They traveled across the globe and they spent day and night in teleconferences. At the end, everything has to fit together just perfectly. And that was what we saw at the end when the instrument building happened, and then the design concept came, the instrument building happened, testing happened, and now it all ended with the successful launch yesterday evening. And the next step will be, unfolding of the boom and the reflector, making sure that the radars are working fine. So far, everything checked out. The health of the satellite is coming out perfectly. And then once everything checks out fine, we'll be getting this unprecedented amount of data, and that's for the benefit of the society.
In terms of challenges?
There are always challenges because, working not under the same roof and not under the same processes and cultural differences, but that's where the the beauty of this collaboration came because we learned from each other. Our engineers and scientists, the amount of learning that happened because great sets of minds working together, we got much more than any one of us, any one of the agency could do by themselves. So the collaboration was the best satisfaction and more, awarding.
Right.
The collaboration and this is the pathfinder because we learned so much from each other, and so that we can apply all that. And we expect that in the future we'll be doing more missions, and we'll just use that experience from what we learned from this one.
I'm going to ask you what next.
So what's next with NISAR? NISAR just launched yesterday, very successful launch. We're going to have 90 days of commissioning. What this means is we've got to get the radar reflector open. We got to make sure that everything's working. We also launched into an orbit of 737 kilometers, and we need the next 45 days or so to bring it up to 747 kilometers. So it's got to rise up. As it's doing, all the different subsystems on the satellite will be opening up. And then we'll be starting to collect data near the end of this, and all of our data from about 3 months on, by day 90, will be free and open to the world. So all the data that NASA's collecting and ISRO's collecting will either be accessible through India's web portal or through NASA's web portal at the Alaska Satellite Facility. All free and open, and anybody can go ahead and take advantage of this data. Once NISAR starts collecting data, this is where the science begins, as well as all the applications. This is what this collaboration has brought about for this last 10 years, 10 months, almost to the day of which we signed the agreement for NISAR, how long it took us to build it, and we're now there. We're on the precipice of actually envisioning and realizing this dream. And so from there, we'll have scientists from ISRO and NASA working together, both to check out the data, make sure everything's going well, and also taking advantage of the data. For example, we had the large earthquake yesterday in Kamchatka. NISAR is going to be uniquely able to image earthquakes like this anywhere in the world to help with the urgent response effort, but also understand some of the fundamental geophysics that drive these earthquakes. And what we learn on the Kamchatka earthquake, we might actually be able to apply to other fault zones around the world, perhaps maybe even the Himalayas, although different fault systems. There are things that we could learn from each earthquake, and NISAR is going to be able to uniquely measure it. So what's next with NISAR is the fun begins. We're going to be able to deliver all this data to the world, and anyone around the world can access the data effectively on their iPhone, on their smartphones. Anybody with a smartphone can access data and begin working with it. And we have a number of products, and ISRO has a number of amazing products that will be also available.
Professor, in the earlier major collaboration between ISRO and NASA with respect to Chandrayaan, that had led to the discovery of presence of water molecules on the surface of the moon. This time, what kind of a breakthrough you're looking forward to?
That is a wonderful question, and of course, it is hard to predict what we're going to discover in the future. But NISAR is set up because it's observing the whole globe all the time to really provide us the observations which we believe will help revolutionize our understanding of how earthquakes work. For instance, we have a very strong collaboration as a result of the NISAR project to study the Himalayas and to understand the potential for very large magnitude 8, magnitude 9 earthquakes up along the entire Himalayan front. We expect that kind of analysis that explores the basic physical process that links a natural phenomena to potentially very hazardous phenomena to be something that we will see lots of from NISAR. Another example would be monitoring volcanoes everywhere on the planet, right? Anywhere which is not covered by water. These kinds of observations, it is very unusual in the past to have a systematic observation pattern, again with this free and open data, that lets curiosity drive the scientists. I wonder if, and they can go look, right? And a student can say, I wonder if, and everybody has access to the data. And what has been wonderful with the collaboration is we've spent a lot of time developing the tools, the software that allows new researchers, new students at small universities, big universities, and research institutions alike to be able to take advantage of these data, because we can't also predict who is going to make the big discoveries, not just what, but who. It may come out of a place that we don't expect, and that is really the power of this kind of global observatory.
This project also showcases India's strength in terms of building something big like this at a largely lower price. Was there also an opportunity or any lessons to be learned from this experience for the US or for NASA?
Thank you for the question. But the way the international collaboration works between any two space agencies, it is not the question of exchanging any funding, but rather it is exchange of hardware. So NASA built hardware that were delivered, and ISRO built hardware and that were delivered, and we planned it that way. Now the question for whether NASA can learn about how to do it at a lower cost, I don't think that is something that we would like to discuss. It is not, the international collaboration does not allow for that. It is more like we built it and it's a big investment for us, and the return for investment is what we concentrated on. How much we are going to learn from this, and whether that was the most important question that we are trying to answer here.
At any point, were there concerns regarding whether GSLV would perform? It's popularly called as naughty boy. Sometimes it does let it down.
We trust ISRO, and ISRO has a long history of launching rockets, and so we are believing in what they were. So yes, I know that ISRO had a launch failure, and there was adequate review with it, or in-depth review with it, and we have every confidence with our ISRO partner.
Yesterday, the team, soon after the launch, thanked the families profusely. Give us a sense of the kind of contribution the families make and the kind of sacrifices they do make.
That is a wonderful question, because it reminds us that when you build a mission of this scale, it is really a group experience. It's a group effort, and that group extends to beyond the technical staff. It includes the families, and I think probably people would say that the biggest sacrifice is time, that people spend traveling from one country back and forth, that when there are urgent things to address, that they work 24 hours, they work weekends, they work holidays, they miss birthdays, and so on. So it's really about time that is dedicated to the mission and therefore is not at home. But in the end, we know we're all driven by this desire to help society, to understand the natural world around us, and it is a decision that we collectively have taken to make this sacrifice because we expect that the impact will be enormous.
That was a small team from NASA and Caltech talking to us on the successful launch of NISAR at Sriharikota. Hope you liked it. See you again next week. Have a great weekend.